we have various concentration terms like molarity, molality, we have percentage by mass, we have got the mole fractions represented by psi, we have got parts per million, we have got normality, we have got lots of terms like that. Now the kind of common questions or the kind of common problems that we face related with the calculations of molality, molarity, or percentage by mass, or mole fraction, or parts per million is how do we convert the concentration in molarity into molality, or the molality into molarity, or the molarity into percentage by mass, or the percentage by mass into molarity. So the interconvergence of this concentration terms that creates some challenge. So in the course of this discussion, we would become familiar or comfortable to convert the one concentration term into another concentration terms. So let's look into it one by one. So let's say we have let's say we have a concentration term by that is given in terms of molarity. So let's say we are given 2 molar concentration. Okay, so what does 2 molar means? Or let's say 2 molar sulfuric acid. Okay, whose density, let's say density of sulfuric acid solution is given as 1.84 gram per ml. Okay, so what are they asking? They are asking us to convert it into the mole fraction, convert it into the molality, or convert it into percentage by mass. Okay, these are the common conversion terms, so let's just focus on that. Now before we move ahead, we need to understand what does molarity means. Molarity means the number of moles of the solute. Okay, the number of moles of solute which is there in 1 liter of solution. Okay, so what we have is, we'll have this term which is in 1 liter of the solution. That means we are going to consider in how much volume of the solution we are taking. So volume of solution in liter. Okay, so here as per the given condition of the problem, we have got 2 molar, so it means we have 2 mole of sulfuric acid. Okay, sulfuric acid would be the solute, and if the solvent is not mentioned, that means we are going to add the water in that 2 mole of sulfuric acid to make it into 1 liter of solution. Okay, so if it would have been, so let's just put this 2 mole of H2SO4 in the solution in a more convenient form. If we put it here, let's say we have got the sulfuric acid and we have got the water as a solvent that we have mixed and prepared our solution. It's better like if we write some representative form for the solutes and the solvent that we are using. So let's say for the solute, which is sulfuric acid for us, let's keep the representation A, and for the solvent, that is water, let's keep the representation B. So the amount of the solute, okay, the amount of the solute that we have and the amount of the solvent that we have, it can be represented by the weight and it can be represented by the number of moles. Similarly, for the solvent, it can be represented by weight, and it can be represented by the number of moles. Okay, so together the weight of the solution would be weight of A plus weight of B, and similarly for the moles, it would be number of moles of A plus number of moles of B. So as per the conditions of the problem, okay, what is being given to us? 2 molar H2SO4. And what does 2 molar H2SO4 means? 2 molar H2SO4 means we have 2 moles of the solute. So solute, that is sulfuric acid, is 2. Okay, so we don't have any more other informations. We don't have the information for the weight of the solute, the weight of the solvent, the number of moles of the solvent, the total mass of the solution, or the number of moles of the solutions. But still we can maneuver around and create the data for this. So let's see how we can do that. So let's first look into the first information that we have, the number of moles. That is equal to weight over molecular mass. Okay, so which is equal to 2. So we know that the molecular mass of sulfuric acid, okay, the molecular mass of sulfuric acid is 98. Okay, so if we put the value of molecular mass of the solute, that is sulfuric acid, as 98, we'll get it as 2 into 98, that is 196. Okay, so the weight of A is 196 for us, and if we need the information of all of these other terms which are still vacant, okay, we need to look at the other additional information which is provided to us in the problem. So the additional information that we can see is the density of the solution. The density of solution which is given to us is 1.84 gram per ml. Okay, so what does it mean? The density of solution, is 1.84 gram per ml. Okay, so what we have is, what is the formula of density that we know? The formula of density is the mass of solution. Okay, this is the density of solution, so it is mass of solution by volume of solution. Okay, so what we have is, this is 1.84 gram per ml. So the mass of the solution that we have is weight of A plus weight of B. The volume of the solution, as per our molarity. Okay, if we look into the value that we have seen a while ago, the volume that is given to us for the solution, the volume is 1 liter. Okay, so if we put this value 1 liter over here, okay, so what we'll have the weight of the solution, which is equal to 1.84 gram per ml into 1 liter. So this units, the one of the unit is in milliliter, the other unit is in liter. So let's convert this milliliter, liter into milliliter. Okay, so this is gram per ml, and if we convert 1 liter into ml, it will be 1000 ml. So milliliter will get cancelled out. So what we'll have is, we'll have 1480 gram. This is the mass of the solution. Okay, so the mass of the solution is 1840 gram. So the mass of solution is 1840 gram. And what is the weight of A? 196. So which means the weight of B would be 1840 minus 196. So if we subtract 196 from here, we'll get the mass as your 4, and then this would be 14 minus 9, that is 5. So that is 7 minus 1, 6, 1654 gram. Okay, so we'll have the value 1654 gram. Okay, so now once when we have the number of moles, once when we have the weight, we can have the number of moles of B. So number of moles of B, the formula that we know is weight of B by molecular mass of B. Okay, so the weight of B that we have is 1654, and the solvent that we have taken. Okay, just in any case, if the solvent is not mentioned, you should always keep in mind that the solvent by default, okay, or the solvent of choice for us is water. Okay, so what we have is we have got the solvent, that is water, so the molecular mass of water would be 18. Okay, and 1654 divided by 18 is 91.88. okay, so for our convenience, let's just take a round figure. So let's say this is 92 mole. So the number of moles of B that we have is 92. So together 92 and 2, it would be 94 moles in the solution. Okay, so now once we are ready with this format of the table or the chart, okay, once when we are ready with this, we can move ahead and convert it into any term that we wish. Okay, so let's say we want to find the mole fraction. Okay, let's say we want to find the mole fractions. So what we're going to do, so the formula of mole fraction that we have is the mole fraction, let's say for sulfuric acid, that would be equal to the number of moles of the sulfuric acid out of the total. Okay, so the number of moles of the sulfuric acid that we have is 2, and the total is 94. Okay, so that is 1 over 47. Okay, that is the mole fraction of sulfuric acid that we have. Now similarly, if we want it for molality, let's say the molality is the number of moles of the solute. Okay, we need to look into the definition again and again and try to understand its meaning. So the meaning of molality is what is the number of moles of solute that is present in 1 kg of the solvent. Okay, that is per kg of the solvent. So we are going to consider the weight of the solvent in kg. So what we have is the number of moles of solute, that is sulfuric acid, okay, that is 2 moles, and the weight of the B, this value is 1654 gram. Since it is in gram and we want it in kg, so we'll just divide it by 1000. Okay, so what we'll have is we'll have 2 into 1000 over your 1654, which equals to 1.2 molal. Okay, this molal, since it is in number of moles over your kg, so we could have also written this as 1.2 mole per kg. Okay, and the third question that we had was, let's say this is A, this is B, and the third question that we were asked was percentage by mass. So percentage by mass, if we look here, the percentage by mass, so what we have is the formula for percentage by mass is the weight of the solute out of the total weight multiplied by your 100. So the weight of the solute that we have is 196 and the total mass is 1840. So we'll just write it here, and then this is multiplied by 100, which is equal to 10.6%. Okay, so since percentage is all about the fractions or ratios, so we won't have any unit, so we need to be careful with this. Here also, as we can see over here, there is no unit in mole fraction. Okay, and other thing that we should always remember is, if it is a fraction like the mole fraction or like percentage by mass, okay, if it is, if it is in fraction, you should always know that your answer can never be greater than 1. Okay, the mole fraction, it should never be greater than 1. It should be less than 1, or it may possibly be equal to 1, but it can never be more than 1. Okay, you need to remember this. And here similarly like that, the percentage by mass, okay, the percentage by mass, it cannot be greater than 100. Percentage means out of total of 100. Okay, so we can never have a value that is higher than 100. So in case if you get a value that is higher than 100, that means something is wrong with your calculations. So we need to be careful with this whenever we are trying to calculate for the mole fractions or for the percentage of mass in terms of the value of the answer that we are getting, or like if we are going to consider the units. Okay, so let's move on to the other point. So let's consider another case scenario. In one of those case scenario, let's say we are given 2 molal H2SO4, the sulfuric acid. Okay, so let's consider the same scenario, the density of sulfuric acid, which is 1.84 gram per ml. The density of sulfuric acid, which is equal to 1.84 gram per milliliter. And what they are asking us is, they are asking us to find the molarity, the mole fraction, the percentage by mass, the common concentration terms, okay, that we come across very often. So in that case, what we're going to do, so first of all, the thing which is provided to us, or the one that we already know, let's focus on that. So 2 molal H2SO4. Okay, what does 2 molal H2SO4 means? Okay, so before we move ahead, let's focus on the term molal or molality that is given to us. Now 2 molal or a molal, what does a molal means? Molal means the number of moles of solute. Okay, the number of moles of solute that we have in 1 kg of a solvent. That means the weight of solvent in kg. Okay, in 1 kg of a solvent. Okay, this is solute over solvent. Okay, earlier in molarity it was solute over solution. Okay, so there's a slight difference in between the terminologies, so let's just be a little careful with that. So now what we have is, we have, as per the given condition of the problem, we have got 2 molal. Okay, what does 2 molal means? That means 2 mole of solute is there. And what is the solute that we are considering as per the problem? Sulfuric acid. So that means we have got 2 moles of sulfuric acid. And like I have mentioned earlier, if the solvent is not specified, okay, if the solvent is not specified, it means the solvent by default is water. So since it's about mole per kg means 1 kg, so we have got 1 kg. Okay, 1 kg of solvent, and instead of the solvent, what can we write? We can write it as water. Okay, so let's try to create the chart that I have mentioned earlier. So let's take the sulfuric acid, which is our solute, the water, which is our solvent, and then we have got the solution. Okay, so what we have is, we have got the weight of sulfuric acid. We are going to represent it by A, the solvent, water, by B. So the weight of sulfuric acid, the weight of water, the weight of the solution. Like that, we'll have the number of moles of the sulfuric acid, the number of moles of the solvent, water, and then the total moles of the solution. So as per the given condition of the problem, what can we see? We can see that 2 mole of sulfuric acid. Okay, so we have 2 moles of sulfuric acid in 1 kg of water. The mass of water that we have is 1 kg. So 1 kg, if we take it in gram, we'll have 1000 gram. Okay, so the number of moles for the sulfuric acid, the number of moles is weight over molecular mass, and we know that the molecular mass of sulfuric acid is 98. Okay, so that means the weight of A that we'll get is 2 times 98, that is 196. Okay, so we can write it here as 196. So 196 plus 1000, it would be 1196 gram. Okay, and the total moles of the solution, for that we'll need the number of moles of B. So that is, number of moles of B would be again weight of B by molecular mass of B. So we'll have 1000 divided by 18. Okay, just in any case, if you are falling short of time and if you want to produce your answers really quickly, just try to think of 18 as a 20. Okay, so if you think of 18 as a 20, then it becomes easier to divide. So in case if it is 20, then 0 would get cancelled out, so 250 times 100. But at the denominator, since we have a bit of small number, so your answer is going to be a bit higher. So if you divide 100 by 2, you're going to get 50, but since your denominator value is less, so we can come up with this value. Okay, it may be 51, 52, somewhere close to 50. Okay, we are just trying to buy some time so that we can improve our calculation speed and we can arrive at our answers as quickly as possible. So we'll have 52. So this is 52, that is the number of moles of B, and 2 is the number of moles of A. So together the moles of the solution would be 54. Okay, and once when table is ready like this, okay, we understand that if our table is ready, it's like the format for solving the problem. So once when the format is ready, we can move ahead and get our values, the one that we were seeking. So let's say we were asked to get the molarity, we were asked to get the mole fraction, we were asked to get the percentage by mass. Okay, so let's try to get the value of mole fraction. So the mole fraction of sulfuric acid. Okay, the mole fraction of sulfuric acid formula is the number of moles of sulfuric acid out of the total. Okay, out of the total moles. So number of moles of sulfuric acid is 2, and the total moles is 54, that is equal to 1 over 27. And since it is a fraction, so there will be no unit. Okay, and now if we look at percentage by mass, we'll have the formula, the weight of the sulfuric acid over your weight of the solution multiplied by 100. So what we'll have is the weight of the A, that is 196, the total weight is 1196 multiplied by 100. Okay, so which gives us the value 16.38%. Since it is a percent, again there will be no unit. Okay, now we are left with only one term that we need to convert, that is molarity. Okay, so let's see how we can convert 2 molal into molarity. Okay, but here we'll have a scenario. The molarity that we are trying to find, okay, molarity that we are trying to find, its formula is the number of moles of solute that is present in 1 liter of solution. Okay, so as per our table or the chart that we have, the number of moles of sulfuric acid that we have is 2. We can put it here, but the problem is in this chart the volume is not provided to us. Okay, we don't see any volume over here. So if you don't see the volume over here, you can see that we have another set of informations which was provided in the problem, the density of sulfuric acid. So the density of sulfuric acid is 1.84 gram per ml. So if we just focus on density of solution, which is 1.84 gram per ml. Okay, so what we have is, we have got the density formula as mass of solution. So we can write it as weight of the substance, that is mass of the solution, over your volume of the solution. So let's say we want it in liter, so we'll have it like this. Okay, the mass of the solution that is given as per our table, it is 1196. Okay, the mass of the solution. So let's put it here. So that is 1196 over your volume in liter. So if we divide, that would be equal to gram per liter, which we are going to divide in the next step. So if we divide it here, the volume in liter, it would be 1196 gram divided by 1.84 gram per ml. Okay, so which means we'll get our answer in milliliter. So our value would be 650 milliliter. Okay, so if we divide this by 1000, we'll get the volume in terms of liter. Okay, so we can just cancel out 0 0. So this is 65 by 100, that is the volume of solution. Okay, this volume is for the solution. So if we put the value over here, that is 65 over 100, 65 over your 100, so that would be mole per liter. That is the molarity for us. So if you just multiply and divide now, so this is 2 times 100 over 65, so that would give us our answer as 3. Okay, so that means if you have a 2 molal, okay, if you have a 2 molal sulfuric acid concentration, the molarity of that particular solution would be 3 molar. Okay, that is what we have arrived at this point of time for our value of molarity. So now we know how to convert molarity into the mole fractions, the molarity into the molality, the molarity into the percentage by mass. And here in the second part, we have discussed how to convert the molality into molarity, the molarity into the mole fraction, and the molality into the percentage by mass. Okay, so now let's look at the mole fraction. Okay, so from here we'll try to convert the mole fraction into the molarity, the molality, and the percentage by mass. Let's see how we can do it. So let's say we have, in the third case scenario, okay, let's say we have got the mole fraction of sulfuric acid, okay, which is equal to, let's say 0.2, okay, and the density of solution, the density of solution, that is sulfuric acid solution, is equal to 1.84 gram per ml. Okay, so the question is, what is the molarity, what is the molality, and what is the percentage by mass? Okay, we are asked this, and now we are going to try to get the answer for this. Before that, let's try to understand what does mole fraction means. The mole fraction, okay, the mole fraction is nothing but the ratio of the number of moles of the solute over the total moles that we have in a solution. So since we are considering the sulfuric acid, okay, so the solute, okay, the sulfuric acid, we have taken the symbol A. Okay, so let's say we have got the sulfuric acid, we have got the water, which is our solvent that gives us the solution. Sulfuric acid is represented by A, solvent water by B. This is weight of sulfuric acid, the weight of water. Every now and then when we come across such kind of problems, it is always convenient if you create this kind of chart or table, okay, so that it would be easier for you to put the values in the formula and you can get your answers very directly. So let's look into the information that is provided to us. What we have is, we have the mole fraction of sulfuric acid that is equal to 0.2. so that is the, what it means is, the mole fraction of the component, that is sulfuric acid, is 0.2. now it means out of the total of 1. Okay, remember I told you that the mole fraction, okay, for a fraction, the value, the total value is always 1. so since this is the total moles of the solution, so the total value in a fraction is always 1. so out of the total of 1, okay, out of the total 1, the number of moles of sulfuric acid that we have is 0.2. okay, so out of the total of 1, the number of moles of sulfuric acid that we have is 0.2, which means the number of moles of the solvent, that would be 1 minus 0.2, that is equal to 0.8. okay, so that is the total moles of the solution. Now once when we have the number of moles, we can easily get our mass, so which is weight over molecular mass, that is 0.2. so this would be weight of A. We know that molecular mass of sulfuric acid is 98, so sorry, this would have been minus 0.2, so this is 98 into 0.2, so that would be 19.6. okay, so on the other side, if we look over here for the solvent, this is weight of B over molecular mass of B, which is equal to 0.8. for the water, the molecular mass is 18, so this would be equal to 14.4 gram. okay, so this is 19.6, this is 14.4 gram that we have. So if we add the mass of the solutes and the solvents together, collectively their mass will be, this would be your 4, and then we have 34. So together this is 34 gram. Okay, 34.0, that is 34 gram. So once when we have this table, once when our table is ready, that is the format is ready, we can launch our calculation now. So we were asked to find the molarity, the molality, and the percentage of mass. So let's first look into the molality. So molality is, like we have seen a bit earlier, molality is the number of moles of the solute out of the 1 kg of the solvent. Okay, so the number of moles of solute that we have is 0.2. the weight of the solvent, okay, it is 14.4 gram. Okay, so since we want, okay, our mass of the solvent in terms of kg, so we're going to convert this gram into kg by dividing it by 1000, so it becomes kg. So this should be 0.2 into 1000 divided by 14.4. okay, so that is our mole per kg. Okay, and if you just multiply and divide this, you'll get the answer 13.8 mole per kg. Okay, now that is our molality. So if we have to calculate the percentage by mass, if we have to calculate the percentage by mass, so let's calculate the percentage by mass. What we can have the weight of the solute out of the total weight of the solution multiplied by 100. So the weight of the solute that we have is 19.6. okay, and the total mass of the solution is 34. okay, so this is 34, this is gram divided by gram, so it will have no unit, and we're going to multiply it by 100, so our answer would be 57.6%. okay, so now we can see that the percentage, okay, the percentage mass, that the value that we are getting is 57.6. okay, this is much less than 100, so which means our answer should be correct. Okay, now moving to the next part, the density. If we have to calculate the molarity, we'll need the volume. So for the volume, we are going to rely on the density. Okay, the density value which is provided to us is 1.84 gram per ml. okay, so the density of sulfuric acid solution that we have is 1.84 gram per ml. okay, the density of solution is the mass of solution over your volume of solution in this should be simply volume of solution. okay, that would be equal to 1.84 gram per ml. okay, so now what we have is the mass of the solution, that is weight of A over weight of B. The volume, we don't know the volume, and we wanted it in let's just write it as volume. So this is 1.84 gram per ml. So the weight of the solution that we have is 34 gram. So if you just write it as 34 over here, this is volume, so this would be volume, that equals to 34 over your 1.84 gram per milliliter. This is gram, this is gram, gram gets cancelled out. So 34 divided by 1.84 would be equal to 18.5 milliliter. okay, so what we have is we need the volume in terms of liter. okay, if you look over here, we need the volume for molarity in terms of liter, so we'll convert the volume in milliliter into liter. So if we convert the volume in milliliter into liter, we are going to divide it by 1000. okay, so that is our volume of the solution, okay, in terms of liter. So this is 18.5 divided by 1000, so this would be 18.5 divided by 1000. The number of moles of solute that we have, okay, is 0.2. so the number of moles of solute that we have is 0.2, so that is 200 over your 18.5. so now if you divide this, we'll get our answers as 10.81. okay, so that is the molarity. So we could have also written the uh, the unit in place of molarity as mole per kg, sorry, mole per liter. Okay, so instead of mole per liter, whatever we written, we have written molarity, so it's the same. Now we know how to convert the mole fraction, the molarity into the mole fraction. Okay, molarity into the mole fraction, molarity into molality, molarity into percentage by mass. In the second case scenario, we have seen how to convert the molality, okay, into various concentration terms. In the third case scenario, we have seen how to convert the mole fraction into various other concentration terms. So let's look into the fourth case scenario. Let's say we have the concentration term that is given to us in terms of percentage by mass. Okay, so we have 25% by mass of sulfuric acid. Okay, the density of sulfuric acid solution, okay, sulfuric acid solution, let's say it is 1.84 gram per ml. Okay, and they are asking us to find the molarity, the mole fraction of sulfuric acid, and the molality. Okay, so let's move ahead with it. So if we just take the sulfuric acid, let's try to create the format sulfuric acid and water, that gives us the solution. So we have the sulfuric acid mass as weight of A, the mass of water as weight of B, and this is the weight of the solution. And we have the number of moles of A, we have got a number of moles of B, this is the total moles of the solution. Okay, so in order to fill this table or the chart, we'll have to rely on this understanding of this terminology. Okay, so what we have is, we have got 25% by mass of sulfuric acid. What does it mean? It means that out of the total of 100, percentage is all about out of the total of 100. Okay, out of the total of 100, the amount that we have is 25. Okay, so the 25, this is the concentration that is representing sulfuric acid. So that means if the amount of sulfuric acid that we have, amount in terms of weight, okay, if the amount of sulfuric acid that we have is 25, the amount of this represents, the one at the denominator represents the amount of the solution in terms of the mass, which is equal to 100. So 25% means 25 over 100. And what does 25 represents out here? If you have 100 grams of the, if you have 100 gram of the solute, of the solution, that means 25 gram would be the solute, that is sulfuric acid for you. Okay, so by looking at this, we can get the value of sulfuric acid as 25 gram, and the solution mass is 100 gram, which means the weight of the solvent, it would be 75 gram. Okay, so it's very simple and easy to understand. And after that, now if we put the ratio of the weight over the molecular mass, we can have the number of moles. So this is 25 over 98, which is the molecular mass of sulfuric acid. So you can just take the assumption that 98 is as good as 100. So 25 over 100 is 1 by 4th. 1/4 is 0.25. Okay, so even if it is not exactly 0.25, but the value that we would get would be somewhere very close to it, so we can take it as 0.25 to save our time for the calculations. So similarly, for the number of moles of B, we can have the weight of B over the molecular mass of B. So weight of B that we have is 75. The molecular mass of water is 18. So 75 over 18 is 4.1. So we can just neglect 0.1 and we can write that it is as good as 4. So 4 and 0.25 together, this moles of the solution would be equal to 4.25. Okay, so this is the total moles of the solution. Now that our table is ready, okay, so we can move into the terms that we want to find. Okay, we want to find the molarity, we want to find the mole fractions, we want to find the molality, and if we remember, like for the molarity we need the volume. Okay, and volume here in this table, okay, the volume is not there. We don't have any volume term over here, so that means we need to find the volume if we want to get the value for the molarity. Okay, but to find the volume we would need some additional informations. That information would be our density. Okay, we'll take the help of density, the information that is provided to us. So the value of density that is provided to us is, let's say that density, okay, is 1.84. so let's just write it here. So we have got the mass of solution over your volume of solution, so that is 1.84 gram per ml. Okay, so the total mass of the solution is 100 gram. Okay, this value is 100, which means the volume of solution would be equal to 100 gram divided by 1.84 gram. Okay, so that means this is in gram per milliliter. So gram, if it gets cancelled out, we'll get the volume in terms of milliliter. So 100 divided by 1.84 is 54.3 milliliter. So if we just convert this milliliter into liter, okay, we can have like 54.3 divided by 1000. This is in liter. Okay, so now we have our volume. Okay, so when we have our volume, that means we can easily get our molarity. So we'll get our molarity as the number of moles of the solute by volume of solution in liter. The volume that we have is 54.3 over your 1000. The number of moles of solute that we have is 0.25. Okay, so if we just put it over here, this is 0.25. okay, so now what we can have is, if you just multiply and divide it, this would be 25 over 100, and 1000 would go up, and this is 54.3. so 54 is as good as 100, so as good as 50, so we can roughly take it as 50. So this is your 2 times, and then 0 0 if we cancel it out, so roughly we'll have 2 molar. Okay, so that means if your solution strength or the concentration is 25% by mass, our molarity would be, will have 5 molar, isn't it? The one that we have calculated just a while ago, our molarity would be 5 molar. Okay, this would be 5 molar. And if we want it for the mole fraction, okay, if we want it for the mole fraction, we can just rely on this table. So let's say we have a mole fraction of sulfuric acid, so that is the number of moles of the sulfuric acid out of the total. Okay, so the number of moles of sulfuric acid that we have is 0.25, and the total that we have is 4.25. okay, so if we divide this, we'll get our answers at 0.05. okay, so since the mole fraction, the total amount is going to be 1, the maximum possible value, Okay, it should not be more than 1, and the value that we are getting is 0.05, that is much less than 1, so which means our answer should be possibly correct. Okay, and the next concentration term that we are interested now is the molality. So molality is again very simple. If we want to find the molality, we're going to have the formula, that is the number of moles of the solute out of the total out of the 1 kg of the solvent. So the number of moles of solute that we have is 0.25, and the solvent mass is 75, but 75 is in gram. So if you want to convert the gram into kg, the term that we need, we're going to divide it by 1000. So this would be 0.25 divided by 75 multiplied by 1000. Okay, and its unit at the, this is mole over kg, so this unit would be mole per kg. Okay, now if we multiply and divide this, we'll get our answer as, we could have written like this: 25 over 100 into 75. This is 1000, so 2 zeros will get cancelled out. 25 3 times 75, so our answer should be 3.3 mole per kg, or simply molal. Okay, so this way we can convert the percentage by mass into the molarity, into the mole fractions, and into molality. Okay, so I hope it's clear with everyone. So what have we done? The most important thing that we need to do is first try to understand the meaning of every terminology that is being provided to us. Let's say you work on the meaning of molarity, and once when you understand the meaning of molarity, you try to create the chart or the format on which we will work, okay, based on that informations. And once when you put the formulas for other terminologies, you'll get the answers. Okay, and after this, the terminology, okay, that we had was molality, and we had to convert this molality into molarity, the mole fraction, and the percentage of mass. So what we're going to do is make sure that you understand the terminology properly, and after that you create the chart or the format, and once when it is ready, you just have to simply put the formulas in the right places and you'll get your answers. Okay, and the same goes in the third case also. We had the mole fraction value, and we have derived the values from that amount of mole fraction which was given to us. Okay, we have generated the values and we have put them in the table, the format which would make our work very easy. And once when it's ready, we can convert them easily into molarity, the molality, and the percentage by mass. So I hope it's clear with everyone. Thank you.